This is an RNZ podcast.
Ngā mihi and welcome to Elemental, a podcast from RNZ celebrating 150 years of the periodic table. We're on an alphabetical journey through the chemical elements, we being me, Alison Ballance.
And me, Allan Blackman from the Auckland University of Technology. Today we're going to find out about the most reactive of all the elements, fluorine.
Now that sounds exciting, and I gather there's something that you need to get off your chest first about fluorine. Let's cut straight to the chase.
Okay, so we talk about fluorine, we talk about fluoride, and they're two very, very different beasties. And the whole reason I got into science communication was in fact a letter to the editor which said that we shouldn't put fluoride in water because fluorine is in the nerve gas sarin. And so obviously if it's a nerve gas, it can't be good for you, so why are we putting fluoride in our water? And I was quite horrified by the fact that they actually printed this letter, and so I wrote a little rejoinder, and I guess there it all started.
And here we are. So tell me the basics for fluorine and then explain to me what fluoride is to fluorine.
Okay, so the vital statistics, fluorine, chemical symbol F, atomic number 9, which puts it right at the top right-hand side of the periodic table, a very privileged position there. Now, what's the difference between fluorine and fluoride? Fluorine, as we will find out, is a highly, highly toxic gas with the chemical formula F2, and that exists as fluorine molecules. Fluoride is what happens when you take a fluorine molecule and give it 2 electrons. And you then end up with 2 fluoride ions, and they have the chemical formula F-. There is a big difference between them, as hopefully will become apparent as we go on.
So how long have we known of fluorine for?
It was first known that something was funny, I guess, with a particular compound, and this was a thing called fluorspar, or fluorite. Nowadays we call it calcium fluoride. This was a mineral that was found to emit light when it was heated, and in fact this is where the name fluorescence comes from.
Really? I've never made that connection. Fluorine, fluorescence, of course. Where does the name fluorine actually come from?
Well, it comes from the Greek, and again, forgive my pronunciation, fluere, and that means to flow. And it was finally isolated in 1886. Certainly there was evidence for its existence, but the actual element itself was extraordinarily difficult to isolate for the mere fact that it is so reactive. So the guy who got this in the end was one Henri Moissan, and he won the Nobel Prize in 1906 for doing this, which really back in that time must have been an extraordinary achievement. So as I say, it is very, very reactive. It's a pale green gas, and really it reacts with all the elements on the periodic table with the possible exceptions of helium, neon and argon.
I'm just wondering how you store it then. If it's really reactive,
Aha,
you've made
yes.
the gas.
Yep.
How do you keep it without just it glomping onto anything else that's lying around?
What an excellent question. So what it's normally kept in is nickel cylinders. And what happens is that as soon as you put it in the nickel cylinder, it reacts with the nickel and it forms a nickel fluoride coating on the inside surface. And that nickel fluoride coating passivates the rest of the surface to further reaction with fluorine. So you can actually store it inside nickel cylinders. And just to give you some idea of just how reactive it is and just how dangerous and why people shouldn't work with it, I had a visitor to my lab many, many years ago who worked in a laboratory where they had a fluorine generating contraption. And somebody managed to leave the tap open one day, and accidentally this guy put his thumb over the outflowing fluorine gas, and his thumb caught fire.
Oh, ouch. Yuck.
So yes, it is very, very, very reactive. Obviously, it's going to kill you if you inhale it. It's extraordinarily nasty like that. So that's fluorine gas. You can also make a thing called hydrofluoric acid, which has got the chemical formula HF, and that is also extremely nasty. You don't want to spill that on your skin because what happens is it keeps burning and burning and burning despite you putting water or whatever on it. And the only antidote to that is a thing called calcium gluconate. So you have to be very, very careful when you're working with hydrofluoric acid. Now, having said that, we've got all the nasty parts of fluorine out of the way. Fluorine is, in fact, an essential trace element in humans. And you mostly find it in the bones and in the teeth. So if it's an essential trace element, it can't all be bad. And what is also found is that many synthetic drugs, so people have estimated around about 15% of all the drugs on the market actually contain fluorine, and these are fluorine atoms. The reason being that it aids in fat solubility. So when you want your drugs to get into fatty parts of the body, that is how you do it.
So important in health, but highly toxic at the same time. It just depends a bit on the quantity and the state it's in.
Indeed, like any poison, I guess. And one very emotive, I guess, poison in which fluorine is found is 1080, okay? The name for 1080, the chemical name, is sodium fluoroacetate. And in fact, this is a natural product. 1080 is indeed a natural product, and it comes from the Hefbla plant in southern Africa.
It doesn't look like that when you spell it.
I know. Now, I actually asked an Afrikaans speaker how to pronounce that, and it's a Hefbla, apparently. So.
I'll just spell it for our listeners, Gifblaar.
Yes. So, again, forgive as per usual, forgive my pronunciation, but it is a natural product. That is probably news to quite a few listeners.
Now, you also get fluoroacetate in lots of plants in Western Australia. Mm-hmm. This is me putting my zoologist hat on, where native species are able to safely eat them because they've just evolved with it, basically. But introduced animals can't, and they die. So the commercial product, as you've said, 1080, is sodium fluoroacetate. Mm-hmm. And they do actually use it to control feral cats and dogs in Western Australia. And the Department of Conservation in New Zealand here is going to use 1080 over 1 million hectares of conservation land this winter to control predators, namely introduced rats and stoats. And that's because the rats and stoats are on the verge of a massive population explosion following a mass seeding event in our forests this summer, and they will go on to eat millions of native birds if we don't do something. Mm-hmm. And I think one of the things that people don't understand is that we in New Zealand are uniquely able to use 1080 for pest control because we don't have any native land mammals here except a couple of species of bats. So in my book, that's a great use of fluorine. What's another use? I
totally agree with you on that, Alison. I think it's a very, very useful weapon, I guess, in our fight against all of these nasty imported species. Anyway, another use, this is a slightly nasty use as well, uranium enrichment. So if you want a nuclear power or a nuclear bomb, then what you have to do is to separate two isotopes of uranium, the two naturally occurring isotopes, uranium-235 and uranium-238. So most uranium is 238, but 235 is the fissionable isotope. So then the question then becomes, how do you separate those two? And what you do is you make uranium hexafluoride, UF6 is its chemical formula, and it really, really surprisingly is a gas just above room temperature, which is very, very unusual. And what you then do is you put this gas in an enormous great centrifuge. And inside the centrifuge, what happens is that the heavier version of UF6 containing the 238 isotope will go to the edge first, and it will separate slightly from the uranium-235 isotope. And so if you do this lots and lots and lots of times, you can then up your concentration of uranium-235 from less than 1% up to around about the necessary 4 or 5%, which is what you need for fission.
Well, you're the chemistry professor, and I'll take your word for it. So just coming back from nuclear reactions, at home then, I might have fluorine compounds in my medicine cupboard, in the bathroom in my toothpaste. What else?
One that everybody probably has heard of, a little thing called Teflon. And the discovery of Teflon was totally accidental. So Teflon is the non-stick coating on your frying pan. And this was first discovered in 1938. A guy by the name of Roy Plunkett was working in his laboratory, and he had a cylinder of a gas called tetrafluoroethylene. And it was stated that this contained 1 kilo of the tetrafluoroethylene. He only got 990 grams out of it, so the story goes. And he was intrigued as to what had happened to the other 10 grams. And so, don't try this at home, kids. He decided to cut the cylinder in half. And he found this white powder in the cylinder, and that white powder was eventually shown to be Teflon.
Thank goodness he did that, though. So from pest control to clean teeth and frying pans, fluorine compounds are very versatile. That's it for this episode of Elemental. But we'll be back next time with francium.
And until then, you can listen to this episode again if you want, or indeed all of the previous episodes at rnz.co.nz/chemistry.
We are also a podcast in all the usual places, Apple Podcasts, Spotify and many others. Why not subscribe if you haven't already? Thanks heaps for your company. Catch you next time. I'm Alison Ballance.
And I'm Allan Blackman. See you later.